Hello everyone. In this video, I will show you how to convert binary number to a hexadecimal number. For example, we have 10010011. The first step that we have to do is to divide this binary number into nibbles or group of 4. Nibble means 4 bits. We must start from the right. So from here to here, we have the first nibble or first group. Then from here to here, we have the second group. So we have two nibbles or two groups. We will deal with these two groups separately. The next step is to use the place values, the binary place values. Remember our previous videos, we used the place values of the binary number to convert the number to denary. So same here, 8421 place values. So we will multiply this 1 to this. So we will have 1. We will multiply this bit to 2. We'll have 2. And then we will add all the results. We will multiply 0 to 4 and it will give us 0. And then we will multiply 0 to 8 and it will give us another 0. So the sum here will be 3. It means that this nibble or this group is equivalent to 3. Okay, then we will do the same to the second nibble or second group of 4 bits. We will use the same place values 8, 4, 2, 1. Remember, we are dealing with this separately. So we are using the place values separately. 1 times 1 is 1. 2 times 0 is 0. 4 times 0 is 0. And 8 times 1 is 8. So we will add 8. So 8 plus 1, it will give us 9. Actually, these digits are in denary, but then denary 0 to 9 is the same as hex 0 to 9. But denary 10 to 15 is actually A to F. It means that the hexadecimal equivalent of this binary number will be 93. And then we can use this notation to indicate that this number is base 16 or hexadecimal. All right. Let's have another example. Let's say we have 101100. In this example, you will notice that we only have 6 bits. Okay, again, the first step, we have to group the binary number into nibble or group of 4 bits from the right. So from here to here, we have 4 bits. And from here to here, we only have 2 bits. If we only have 2 bits, we can add another 2 bits here, 2 zeros, in order for us to have 4 bits. Okay? Next step is to use the place value 8421 for each nibble. So we have here 8421 and then here 8421. The next step is to multiply each place value to each bit and add the product. So 1 times 0 will give us 0, 2 times 0 will give us 0, 4 times 1 will give us 4, 8 times 1 will give us 8. We will just add these products and we will have 12. And for this, we have 1 times 0 is 0 and 2 times 1 is 2. And then we have 4 times 0, 0, 8 times 0, 0. So we only have 2 for this nibble, okay? And then since we got 12 here, this is actually a denary, we have to convert this to its hex equivalent, wherein A is equal to 10, B is equal to 11, C is equal to 12, D is 13, E is 14, and F is 15. So 12 is C in hexadecimal. So this is C. We will just concatenate these 2 and C together and then use the notation base 16. And this is the hex equivalent of 101100. So that's it. In the next video, I will show you how to convert hexadecimal to binary numbers. So stay tuned. Bye.